Welcome to the demonstration of the Waypoint Path Generator utility. In a previous video, I showed how the utility could be used to create circular paths, helical paths, and then be able to join those individual paths together to create a fairly complex path for your drone to fly. In this second video, I'd like to show how you could use the utility to create a path that I generally call a survey grid path, where you want to cover an area, fly over an area with your drone with the camera pointed downwards, and take a series of photographs that you're going to later stitch together. Notice on the screen I currently have two paths shown. The path on the right is a rectangular grid path, while the path on the left is what I refer to as a polygon grid path. The other difference is between the two paths is the path on the right is configured for the drone to take individual photographs that can later be stitched together into a panorama, whereas the path on the left is set up for the drone to fly to take video along its path. Before I get started in the actual generation of the paths, we'll examine the configuration of the camera. You can specify a horizontal and vertical focal length, which at an altitude of 30 meters currently would result in an image size of about 50 by 40 meters on the ground. You can also specify an image overlap so that as you take images, say in the example on the right, each image is guaranteed to overlap the previous one by a certain percentage, okay, which would allow the stitching software to find artifacts between the images to match up for the stitching to work. I'm just going to leave these values alone. I'll delete my paths and zoom in on this football stadium. Let's just zoom in a little bit, and okay, with that centered, I'm just going to right click and say add path rectangular. Now the yellow rectangle you see represents the length, which is defined as the direction along the direction that the drone is flying, and the width is basically the length and width of the rectangular area that you would like the drone to cover. Now currently the algorithm is written to allow the drone to fly to the boundaries of the rectangle along the length, but keep within the boundary of the rectangle, and also using the altitude to calculate the optimum number of rows that you need to cover this area. We can adjust the heading of the drone, so I'm just going to take this up to about, let's make it 357. And I'm going to change the length of the rectangle to make sure it covers enough of the stadium. I'm happy with the width. I'm not going to output a start and end. And lastly, I'm going to turn on photo mode. I will add the path, and now if I examine the path, the first thing is if I go and look at the path properties of the waypoints, I can see that at every waypoint the camera is pointed downwards. The drone is going to pause for 2 seconds, and then it's going to take an image, take a picture. I'm going to take the same path, and I'm just going to output it to a KML file, and I'm going to generate the camera images, and I'll show you what that means. Once I come over here, I'm just going to double click on the KML file that was just output. I'm going to reload it, and I can see in Google Earth what this path is going to look like. The yellow rectangles represent the area that at each waypoint, the size of the image projected onto the ground, and you can see that the images are being overlapped about 25% along both their height and their widths. So the stitching software should have enough, be able to find enough artifacts to stitch the photographs together. The rectangular grid path, as you see, allows you to specify a rectangular area and cover it with a path of waypoints such that you can take images that get stitched together to form a mosaic. But what happens if the area that you want to cover is not a rectangular area? And that's where the next path comes into play, what I call the polygon grid path. To demonstrate that, I'm going to zoom out and turn on display of polygons. And I'm going to use this L-shaped polygon. This polygon was created in Google Earth and imported into the Waypoint path generator. And selecting this polygon, I'm going to right-click and just tell it I want to create a polygon grid path. Okay. It's going to output a start and end wherever I click, but I don't want to start and end, so I'll just turn that off. I can adjust the heading of this path, and it'll adjust itself accordingly. I can adjust the altitude. Yeah, that looks good. And again, I can either run this in video mode or turn on photo mode, where it's going to take individual photographs. For now, I'll just leave it in video mode and add the path. Okay. Once the path is added, I can now output it into, again, either as a CSV file for Litchi, or output it as a Google Earth path for examining into Google Earth. So hopefully this second demo showed how you can very easily create survey paths to allow you to take photographs for survey purposes to generate a mosaic. Thank you very much.